When a developer sees a new feature request for AI-generated content, the instinctive reaction is to add a simple metadata flag or header comment. It feels like the obvious solution: mark it so search engines know what it is. But this approach is an engineering anti-pattern that actively breaks CI/CD pipelines and corrupts data contracts. Today, we connect that headline to the real engineering trade-offs behind content provenance, moving from fragile headers to deterministic verification methods that actually work in production. The trap begins with how easily developers reach for a text flag when asked to solve trust problems. A simple comment like AI generated or a metadata field seems harmless enough on its own. It is easy to implement and requires no changes to the underlying infrastructure. However, treating AI generation as optional metadata creates structural fragility in any automated system. When you introduce an unverified text tag into a production pipeline that expects strict schema compliance, parsing failures become inevitable without any code change from the developer's side. This isn't just theoretical noise. It is a documented failure mode for autonomous systems relying on static permissions and flags. Research indicates that 73% of production deployments showed indirect prompt injection vulnerabilities because these flag-based rules failed to account for behavioral drift or unobserved risks. The problem is not the tag itself, but the assumption that a human-readable label can enforce system integrity in an environment designed for deterministic logic. When agents operate with static flags as their only governance mechanism, they fail when faced with unobserved risks where the behavior shifts outside the expected parameters of the flag check. Consider the impact on your development workflow. A CI/CD pipeline is built to validate inputs against a known schema. If an automated system injects content containing an unexpected AI tag that violates this contract, the build fails immediately. This breaks testing suites and halts deployments without any actual code error occurring in the source files you wrote or reviewed. You are left debugging why your production environment rejected valid-looking data simply because it carried a label that wasn't part of the original design specification. Quick resource note: I keep a curated set of Amazon search links in the description for books, gear, and tools relevant to this channel's topics. Some are affiliate links, so I may earn a commission at no extra cost to you. Please consider supporting the channel by using those links if you find something useful. The engineering reality is that we cannot trust an input flag to verify origin when the signal itself can be manipulated or misinterpreted by downstream systems. We have moved past the era where simple text headers could serve as proof of authorship. True provenance requires cryptographic validation and deterministic analysis baked into the inference layer, not optional headers attached after generation completes. This shift represents a fundamental change in how we approach system design, from asking for permission via metadata to proving integrity through mathematical verification before any data ever hits your repository or production environment. The alternative is what we call deterministic provenance, where verification happens through code-first analysis rather than probabilistic tagging. Tools utilizing tree-sitter call graphs can build a verifiable chain of custody by analyzing the structure and dependencies within the generated content itself. This approach scales effectively to massive repositories like the Linux kernel or large enterprise codebases without relying on editable text headers that can be stripped, altered, or ignored by downstream parsers. By using a local verification pipeline built around these deterministic structures, you create a system where integrity is enforced at the build stage rather than hoped for in the output metadata. This shift also addresses the orchestration challenges inherent in modern AI workflows. Successful autonomous systems do not rely on flags to manage context. They use strict isolation and fire, and forget mechanisms that ensure each session remains independent of previous states or injected labels. Implementing test-driven development principles around these generation tasks ensures that the process is verified, not just a tag attached to the output. When you enforce TDD for AI-generated code or content, you are validating the behavior against known constraints rather than trusting a label to do the work for you. We must also confront the human factor in this engineering decision. Behavioral studies show that over 40% of users allowed AI predictions to dictate their choices even when those predictions repeatedly failed. This psychological reliance mirrors the exact trap we face as engineers, assuming that because an input says AI generated, it is safe or verified, rather than verifying the source mathematically. In high-stakes engineering environments, this trust gap translates directly into financial loss and security vulnerabilities. When participants in these studies treated AI predictions as authoritative authority over their own behavior, they incurred earnings reductions ranging from 10.7% to 42.9%. The same risk applies when engineers treat a metadata flag as sufficient proof of integrity without verifying the underlying cryptographic or structural signatures. The choice you face today is between a fast but fragile solution and a slow but robust one. Adding headers that break tests might seem like the quicker path, but it introduces technical debt that will cost significantly more to maintain later. In contrast, integrating verification into your build process creates a system where provenance is an immutable property of the artifact itself. This requires upfront investment in tooling and pipeline design, utilizing mechanisms like tree sitter for call graph analysis or cryptographic signing at the inference layer. The result is a production environment where trust is established through engineering rigor rather than optional text fields that can be ignored by parsers or attackers alike. As you move forward with your own content pipelines, audit your current systems for fragile headers and consider how deterministic verification might replace them. Treat provenance not as a content policy issue but as an infrastructure constraint that must be solved at the system level. The future of AI engineering depends on our ability to prove integrity through code and cryptography rather than relying on labels we can easily strip away or misinterpret. Thanks for watching all the way to the end. I am a one-person team working hard to make each video better than the last. Subscribe if you found value. It is the best way to show support. Drop a comment with your biggest takeaway. See you in the next video.